Mr. Ryan, are you alright?
Yeah.
So let's look at this list. 1, 5, 3, 2, 1, right? Okay.
Yeah.
1, 5, 3, 2, 1. So what's sublist? Sublist.
Continuous.
Sublist. Okay, can you give me an example of a sublist?
1, 5, 3, 2, 1.
Okay, that's a good example. So
1,
okay,
5,
so 1, 5,
3,
3, 2, 1. Look,
2, 1, 1, 5.
if we want to know how many sublists has the same first and the last value. Look, this is a perfect example, yeah, because the first element is 1, the last element is also 1, which is the same. So this is the sublist, good sublist that has the first and the last element is the same. So how many of those in this list? How many of those? 6, yeah? 6, yes. Yeah, why is it 6?
1,
1.
5, 3, 2, 1, and 1, 5, 3, 2, 1.
Well done. So we notice that each single element is the sublist, which also satisfies this, right? Because for each sublist of size 1, the first and the last element is also is also the same. Okay, cool. How can we do this? How can we count it? Define, count. Okay, let's say this nums. Okay, how can we compute this list? How can we count it? Any idea?
Answer.
Yeah, answer. Yeah, how can we count it?
You need to get it out. You can need to just get the answer.
Any idea how
Answer
we?
equals 0.
Yeah, answer equals 0 at the beginning. So any idea how we're doing this?
just said that.
Any idea how can we count it?
Okay, we just count.
We can always do what? Usually we can do what?
Brute force.
Brute forcing. Yeah. How can we brute force?
We just said that.
Yeah. We're done. Brute forcing. How can we brute forcing?
Checking everything.
Checking every sublist, right?
Yeah.
So in order to check the sublist, because sublist we can brute forcing in ON. What's the term complexity? If
square.
ON square, right? So look, n equals length num, right? Look, if this 1, 5, 3, 2, 1, we can check the pairs. Yeah, 1, 5, 1, 1, 1, 5, 1, 3, 1, 2, 1, 1, 2, 5, 3, 5, 2, 5, 1. Okay, yeah. So these pairs are ON square because it's what? It's actually n plus n minus 1 plus n minus 2 plus 1, right? And this is usually is n times n plus 1, right? Divided by 2, but we drop a constant. The term complexity is ON square, okay? So ON square answer equals 0 for I in range what?
Range nums.
N, right? We're going to, and for J, I, okay, let's do I, L is the left of the sublist. For right, in range, start with L and N, right? And then how can we check if the first and the last element is the same? If what?
If 0 and minus 1.
0? So no. We want to check, now that left is L, right is R. How can we check if the left and right is the same, the value? If what? If what?
Left and right.
Left and right is index. So what's the value of left and right?
N. Left the value.
Left is the index and
If N.
nums is the array. So what's the value of the index and L? Remember that day I talked about I and what do you put here? What do you put here?
Bracket.
Yeah, if what? If nums what?
I just said nums.
Nums what?
I
L.
did say nums.
Okay. If nums L equal what? Equal what?
Nums right.
Yeah, nums right. And what? And what do we do?
And then
What do? We do if the first element and the last element is the same. So what do we do?
we plus 2.
Plus what?
Plus 1.
Plus what? I return.
Answer.
Yeah. Okay, so that will be the proof for thing. But look, can we do better? Yeah, can we do better? Look, 1, 2, 3, 1. Let's say. Look, if we use the hash map to remember, the number of times that the number, which number is appear in this one. So can we use that? Look here. 1 appear once, 2 appear once, 3 appear once. But 1 here, we up to this point, including this, we appear twice. So what does it mean? If this number 1 has appeared twice, including this, so what does it mean?
Plus 2.
Plus 2, yeah, because we know it already appears up to 1, right? 1 and 1 appears twice up to this point. So there should be 2 sublists, right? There should be 2 sublists which has the first and the last element the same, right? Got it? So in order to use that, what kind of data structure are we using?
Notebook.
Notebook, okay. Still, we need to use the answer equals 0, okay? And the notebook, let's say sin equals, how do you declare a notebook? Default dictionary, yeah.
Ow.
And then default type is integer, okay? And then what do? We go through each number. For I
in nums.
And current number is I, then we need to update the counter.
Sin I plus equals 1.
Okay, and then we appear, including this number, appear that time. So the answer plus equal what?
Answer plus equals sin I.
Yeah, well done. Yeah.
We're super clever.
Yeah, return.
Answer.
What's your time complexity?
O-N.
O-N, yeah, because there's a loop. We just need to go O-N. What's the space complexity?
O-N.
Why is O-N?
Because we're using a dictionary.
Yeah, okay, that's it. Okay.
Yay! No.
Okay, you tell me what to write. Come on.
Answer equals 0.
Which method you're using? Which one is better?
Answer equals 0.
Come on.
Notebook.
No, which method is better? Come on.
Notebook 1.
Notebook one. Why is that?
Because it's faster.
Why is it faster?
Because we're using pre-forcing.
Why is it faster?
No, notebook. We're using with notebook and
Why is it because?
And like and you can plus 2 instead of the
Because the time complexity, the brute forcing is O-N squared.
Yeah, literally said that.
This method is O-N, right? So if you put it in the time complexity, if this is the size of the input n, and then O-N, right? This is O-N, right? This is n, right? Size n, yeah? And then O-N is this linear, right? O-N squared. Okay? Got it? So which one is better? Clearly this is better, right?
Yeah.
Got it? Yeah? This is 1. This is 1. Okay. Right? 1. If it is less 1, O-N squared is smaller, but n is bigger or equal than 1, right? So it's actually O-N is better than O-N squared because it has lower time complexity. Okay, so let's implement that O-N approach. Okay, so
I think it's 0.
slowly.
Default dictionary.
What default
Sin
dictionary?
equals default dictionary. Integer. .com.
Int means that the value
For
type
I
is
in
it.
nums
Yeah?
column. For I in nums column. Sin I plus equals 1. Oh yeah.
I know.
Answer plus equals sin I. Return answer. Oh yeah.
Okay, that's it. Great job today. Great job. Good job. Bye bye.